Okay, so for this part, we will revisit the while loop with an array. And I would like to show you some interesting properties for arrays, specifically when it comes to assigning values to the array while looping, and also observing what happens to an array if it's not initialized. And let's say we want to peek inside of an array using a while loop, but we have never initialized that array. We'll start with that first and see if you will draw some interesting conclusions out of this exercise. Okay, so let me get started here. So we're going to do include stdio.h, and here's our main controlling function. And in it, we're going to hold the screen as usual. And again, if you don't have a Windows system, do not use System Pause, okay? Use some other features in terms of holding the screen. Return 0. Some other time I might show you different versions of different lines of code you could do here other than System Pause. All right, so now let's suppose we have an array, right? And let's say I have an array of integers. So int my array, right? And let's say it's supposed to have about 10 elements. Okay? All right, so now we're going to do a while loop to look at what's in the array, even though I didn't put any data in this array. I just, at this stage, told the operating system when this runs, hey, you know, I need 10 spaces, each one 4 bytes long, and I want them in consecutive memory locations. It doesn't guarantee me what's inside that memory location. It could be garbage. Maybe this is a great exercise to look at what kind of garbage is in memory as we peek inside the array. So can we create a while loop? And yeah, so, but first let me just do an integer counter and set it to 0. So we want to prime our loop, right? Remember that? Prime your loop. Prime the loop. Right, so we want to prime the loop. Now we're going to set the condition right here. While counter is less than 10, so you know you're going to go from 0 to 9. That's 10 counts. By the time counter hits 10, that condition is false. And so what you want in here is you somehow need to increment counter by 1 every time you move around, right? So, and we're going to use that as our index to view what's in the array. So I could do something like this, printf, and then I could say my array, so display the my array, and put a %d here to show what index we're in, and put a %d here to show the value inside the array. Give me a new line for each one, okay? Again, counter is your index. My array, based on the counter index, is the data in there. Perfect. Now, let's see what this yields. So let me compile and run. And there you have it. I messed up my counter equal counter plus 1. So notice my code here. Obviously, it's not changing the value of counter at all. And this is why I have an infinite loop. And that's because I'm going a little too fast. I need to slow down. Counter equals counter plus 1. Okay, now let's pay attention again. So we're going to compile and run. And there you have it. So what can we say from this? Look here, I got some garbage. Then I got some other garbage, some random garbage already in the array. And that's because I've never set the value for the array. Okay. Could I have set the value for the array in a loop? Absolutely. Could I have initialized the array and making sure that all values will be 0? And the answer is yes. So whatever value you want to initialize it to, so watch this. If you did something like this, just for giggles, first, if you did this, this will not work. Right? So this is not a proper initialization. Let me show you here. If you try to compile this, you're going to get an error. Okay? Now, what if you did curly brace and then curly brace? Now you're going to say, wait a minute, I have 10 elements. You're just initializing one element. Yeah, I'm initializing the first one. I'm giving it a value. Let's see what happens if you do that. Compile and run. And notice all of them are 0. Now, does it have to be 0? Well, it depends. If you want 0 as your first element and everybody else that way, great. If you put a 9, for example, instead of 0, watch what happens. Compile and run. The rest will be 0, except for the first one. So it does initialize the remainder of the elements of the array, and then it will initialize the first data member to that value. So you might have applications that might require that your first data member has a specific value and the rest are 0. This is an appropriate way to code. If you want them all to be 0, then just put 0 here. You know the first member will be 0. The rest will be 0 accordingly. So this is an interesting feature, okay, or behavior of how an array can be initialized. Okay, great. So now, can we populate this array? Yeah, so let me go ahead and populate it right here. So I'm going to do another while loop. So, and it's going to be based on counter as well. So if you do while counter is less than 10, knowing that we started at 0, then make sure that you have a counter equals counter plus 1. So now remember, if you did that, by the time you get to your next while loop, remember to do this. Counter equals 0. Reset the counter. Otherwise, what's going to happen is you're going to be starting at a different memory location where you don't want to be. Let's make that mistake on purpose and see what happens. Well, let's first go ahead and put some data here. And you know what? I'm going to minimize. I'm just going to set up the size. Right, I'm going to write size here. And I'm going to do something like this. Watch this, folks. Int size, and at this stage, I'm going to just make it equal to 5. So technically speaking, the array is only 5 elements. And I'm just going to write size here, and I'm going to write size here. This way, I don't have to worry about putting a number every time. If I want to set the size of the array, I can do it right here at compile time. Okay? Makes life easier, especially now that I'm going to do an interactive program, which means it's going to, at runtime, ask me to enter 5 numbers. All right, if I have 10, it will eat up that much time from me. And the example will still be the same. What I'm trying to say is the same thing. Okay, so I'm going to do a printf, enter an integer. And that is what the user will enter here, so scanf. And then you're going to store it at that location in the array based on what counter is pointing at. So, well, basically what counter's value is. So %d and % my arrays, or my array in this case, counter. So if counter is 0, you're on the first element. If counter is 1, you're on the second element, etc., etc. Now, let's see how this behaves. Now, in this case, if you're doing something like this, there is no need to initialize to 0. So we can take that out if you want. Okay? It will not affect it at all. Even if I left it, it's not a biggie. So compile and run. Yeah, here, in this case it is. So let me just take it out and put size here. Let me compile and run. There you go. All right, so now, let's enter an integer, 4, -1, 2, and 3, and 7. And here they are. Now, let's suppose I forgot to reset the counter. Let's see what happens. Compile and run. Right? So it's going to ask me for my 5 numbers. 1, 2, 3, 4, 5. Okay? Now watch what happens. Press any key to continue. So it skipped completely the other while loop. Why? Because counter is not less than size. okay? Because by the time I left the first while loop, counter was 5. So that wouldn't work, okay? Right, so that's why the second while loop will not work for you in case you forget to reset the counter. So a key element here is you need to reset the counter so that way this condition is always true. Resetting the counter, in other words, it is a priming. You are repriming the variable that you use for your condition prior to entering the loop. And then you need some loop control in here as well. Okay, so I hope this was helpful. Let's go ahead and do it backwards. So let's look at the data backwards. So if you didn't reset it, then we could flip this around and we could say something like this. As long as counter is greater than 0, okay, then subtract counter. Now let's see what would this do. Remember, you're going to get out at some value. Let's see what happens, right? So will it be the right value? Right? Because by the time we get out, it's 5. Do we want counter 5? And this is where the issue might run into. We don't want counter 5. That's outside the realm of the array. Let's watch what kind of problems this will give us. So let's go ahead and put a 1, 2, 3, 4, 5. Now watch this. And we get garbage because there's no such thing as my array 5. And we're missing the 1. So to do something like this, to want to go backwards, you're going to have to prime the loop again, but this time make the counter equal counter minus 1. Otherwise, you're pointing at data in that you never had control over when you were in this loop. You only had control over counter 0 through counter 4 as an index. Counter 5, no. Okay, it's another memory location. So now let's compile and run and see what happens. So as you can see, I know I had 5 by the time I got out of the first loop. Now I'm at 4. So this should be correct now. So I'm going to enter 1, 2, 3, 4, 5. And let's see. Greater or equal to 0. Here's my other error. I need to be greater or equal to 0. You need to include 0 this time. Okay? Since 0 is an index, a valid index for your array. So compile and run. There you go. And let's do it. So 1, 2, 3, 4, 5. There you go. All right, so that concludes this demonstration.